In this lecture, we expand upon our expected value discussion, and now we talk about decision under uncertainty. And it's basically just drawing a table and then using the table to map out your different courses of actions and their consequences. And then we start off without the expected value with just basic utilities, and then we add to that expected value. Okay, so decision under uncertainty is just a fancier way of saying when you get many courses of action, how do you decide? Draw a table, and then there's different kinds of rules you can apply. The three rules you can apply: expected value rule, we covered this in the last lecture, dominance rule, and dominant expected value rule. These are the two new ones. Dominant expected value rule is just expected value rule, but now with a decision problem. And dominance rule is there's no probability, it's just raw weighting, it's just raw utilities. I'll show you examples of these. To illustrate the last two rules, which are the new things for this lecture, we have something called Pascal's wager. Pascal's wager is a famous thought experiment by this guy, Pascal. He was a theologian, multi-talented person, contributed works in philosophy, theology, in mathematics, logic, and other things, right? Pascal's triangle, if any of you know that from from high school math. If not, don't worry. So his question is whether or not to believe in God within the Catholic tradition. And the question is, how do you decide? Suppose you're on the fence and you just don't know, or you haven't even thought about it, right? So before we get to that, let's set up what's called a decision problem. A decision problem consists of three things: a partition, basically possible things that could happen; possible acts, what you could do; and then associated with each of these things, the utilities. The table illustrates this. So let's start off with the dominance rule first. There's a partition of either two things: either God exists or God doesn't exist, not G. The acts are concerning you, right? You either A, choose to be an atheist, or not A, choose to be a believer, not atheist, right? So given this, there's basically two consequences, two things that could happen in the world, and two choices. So the table looks as follows, right? God exists, God doesn't exist, and relative to those states of affairs, you could either A, be an atheist, or not A, be a believer. Well, if you're an atheist, meaning you don't believe in God, and God exists, the utility of that is bad. You burn in hell, right? Negative infinity, really bad. Whereas if God doesn't exist and you're an atheist, no harm, no foul, so let's say that equals 0. If you're a believer and God does exist, then you go to heaven, apparently, right? So plus infinity. Remember, this is a kind of simplified version of the Catholic tradition. The utility, that's what each of these are: utility of being a believer, utility of being an atheist. If the utility in this case, if you're a believer and God doesn't exist, well, no harm, no foul, 0. Dominance says, look at the rows. If there's one that beats and is not beaten by, then choose that act. Ties are okay. But if there's one that, in this case, so this one, let's look across. This one beats that clearly. Plus infinity is way better than negative infinity. And then this one is not beaten by the other one. So there is clear dominance here. This one beats that, and this one there's a tie. Think of like sports teams, right? If you're a truly dominant team, then you beat all other teams, or there's ties. There's no cases where you lose a game. That's basically what the dominance rule is saying. Okay? So in this case, you can apply it. If this were, let's say, 1 and that were 0, then there wouldn't be dominance, because even though it dominates in this case, it beats in that case, it is beaten by in the other case. If this were 1 right here in the first slot, it's beaten by the other case, so there is no clear dominant act. There may be a preferred act, but that's not the same as dominance. Okay? Let's move on now. I have this page you can read. I assume again you've read it on your own. It includes some qualifications. Let's move on now to the one that basically links what we did to this decision table stuff. The dominant expected value rule is basically to set up a decision table, and now you're going to use expected value to figure out which of the courses of actions is the best one. The dominant rule, right? So expected value in this case for our original table, let's add in some probabilities and utilities, right? The probability that God exists times the utility that God exists. It's some fraction, whatever it is. Maybe it's 1, maybe it's 10%, maybe it's 50%, depending on your level of belief or your level of theological commitment. And the utility is, if God exists, and again, you're an atheist, expected value of being atheist, God exists, probably whatever that is, times utility when God exists, which is negative infinity. Negative infinity beats out whatever the probability is. So this part right here is still negative infinity. Plus, probably God doesn't exist times utility God existing. Well, I mean, if God doesn't exist, that's still a finite amount. And if you utility of God not existing, you got some partay in you, right? But it's still a finite amount. Even if you burn the candle at both ends in your life, it's still a finite amount. Your life, if you put that, translate to dollars, your life, if you partay, was $1 million. Ooh, good for you. It's still finite. Negative infinity beats out any finite amount. This expected value of A, if God exists, equals negative infinity. Oops. Now, if you're not an atheist, you're a believer, the probability, again, is a finite amount, but the utility of when God exists is plus infinity. Heaven, right? What could be greater? Plus infinity. It doesn't get any greater than that, apparently. Apparently. If any of you are into religious studies, you'll know that there are much more subtle, what are called soteriological elements as to what that infinite heaven is. Kingdom within, all that kind of stuff is coded as sort of a message hiding in plain sight. The literal interpretation is usually often, like any kind of reading of a book, sort of the false one. It's kind of a bit too shallow. But anyway, so it's still plus infinity. It's really good. If God doesn't exist, I mean, in this case, probably that is still finite. The utility in God not existing, it's still a finite number. Maybe you sacrifice a little and you think, oh, that's not so good. I could have been partaking, so that's negative. But you have community, you have belief, you have family, things that you value, so that has some positive value. Maybe it cancels out at zero, maybe it's positive, maybe it's negative, but still, this number right here, when you aggregate it, when you multiply that times that, is still a finite number. Again, infinity dominates, so you get plus infinity. The expected value of being an atheist is negative infinity. The expected value of being a believer is plus infinity. It's clear which one dominates, right? This one's the better option. This is Pascal's wager. He's saying to you, using logic, you should decide according to this reason. These reasons will indicate to you what to believe. Of course, this doesn't prove that you should believe. It just shows that given Pascal's assumptions, the decision problem we consider indicates you ought to believe. And it should be added, Pascal himself says, the heart has reasons which reason doesn't know. So even if reason here is a way to get you into belief, his level, his depth of faith, as it were, his theological scheme says, yeah, but if you're just choosing soul insurance to save your behind, you're doing it for all the wrong reasons. It's just a start. It's just putting you on the path to realize later that faith is something deeper than that. Anyway, the DEV rule, dominated expected value rule, says given a decision problem and probability distribution, if one act has greater expected value than the other value, this act dominates, so you should do it. It basically says after you calculate the expected values, choose the one with the best value. Okay? And that's it. You're going to have to apply this on the upcoming midterm, second midterm, which is it's right now, actually. And it's got a bunch of stuff in there. It's really just testing your understanding of the material. A lot of this stuff is already laid out, and there's a lot of extra credit as well. And it's sort of practically oriented, so you should think about it carefully. But it's using all of this stuff. You have access to the notes and all the rest. Just put in a good faith effort and try to get the most points you can. All right. Be sure to check out the midterm in La Lima. It's all there.